Welcome to my algebra class. We're on chapter 11, section 7. We're going to be working with multiplying, dividing, and simplifying radicals, and we're also going to do the distance formula. So if I wanted to multiply or divide radicals, anything under the radical sign can be put together. So 3 times 2, I could move those together and say 6. And then the 6 and the 8 I could put under the same radical. So it's 6 radical 48. The largest perfect square in 48 is 16, so that'd be 16 times 3. I would take out the square root of 16, which is 4. And radical 3 would be left. So that would be 24 radical 3. Here, since they're both under the same radical, I can put them together and do canceling. So 8 goes into 24, 3, and 5 goes into 24, 4. So this would be the square root of 3/4, which is the same as the square root of 3 over the square root of 4, which is radical 3 over 2. We're going to be simplifying radicals, and there are 3 things that a radical has to have happen for it to be simplified. There's no number under the radicand that's a perfect square. There is no fraction left under the radicand, and there are no radicals in the denominator. This would not be simplified, the square root of 63, because there's a perfect square in 63. So that would be, breaking it apart, be 9 times 7. So we take the square root of 9 out, which would be 3. And left in the radical is 7, which can't be simplified. B, I would rewrite these as fractions. 7 times 3 is 21, plus 3 is 24 sevenths. And 3 times 2, 6 plus 1 is 7/3, and then I would cancel. And I would get the square root of 8, and the perfect square in 8 is 4. So I take the square root of 4 out, which is 2, and I'd have radical 2 left. And the last part, if I have the square root of 7/8, that's the square root of 7 over the square root of 8. I can have a radical down the bottom, and the square root of 8 is going to have some radical left, so I'm just going to multiply by the square root of 8 over the square root of 8, which is okay because it's a form of 1. And the reason I want to do that is because the square root of 8 times the square root of 8 is a perfect square, 64, which just gives me 8. So that's the square root of 56 over the square root of 64, which is the square root of 56 over 8. There goes the radical. And 56, the largest perfect square in there is 4. So it would be the square root of 4 times 14 over 8. So that comes out 2 radical 14 over 8, and I can simplify that to the square root of 14 over 4. The second problem here, 3 over radical 5. I can't have a radical in the bottom, so I'm going to rationalize it. In other words, make it perfect square. And I can do that by multiplying by the square root of 5. So I get 3 radical 5 over the square root of 25, which is 3 radical 5 over 5. After a while, you'll begin to realize the square root of 5 times the square root of 5 goes to 5. And you can go to 5. And the last part is the distance formula. If I wanted to find the distance from 1, 1 to 3, 4, 1, 1 would be this point here, and 3, 4 is this point here. So I'm actually looking for the distance from here to here, which if I drop down a line here and a line here, I actually have a right triangle. So this is 1, 1, and this is 3, 4. So I'd be looking for C. Now, these are my two legs, and my lengths of my legs could be found by taking this length here would be from here to here, it's 1 minus 3, which would be 2. And from here to here, it's 1. The distance is 3. 1 minus 4 would be 3. And that's what's happening up here in this formula. If I have my two ordered pairs, x2, y2, and x1, y1, all I have to do is subtract the two x's to get the distance for one leg, which I did here. I got that 2. And the distance of the y values gives me my other leg. And y2 was 1 minus 4 quantity squared. So my distance will equal 1 minus 3 is 2 squared, and 1 minus 4 is negative 3 squared. So it's going to be 4 plus 9, and the square root of 13, let's say, to the nearest 10th. They'll tell you what place value to round to. Is 3.6, approximately. So the distance from point 1 to point 2 is 3.6. That concludes the explanation. We're ready to start the assignment. We're on 536, 1 to 12. Have your calculator handy. So problem number 2 on 536. Use the distance formula to find the distance between the given points to the nearest 10th. So number 2, the distance from point 1 to point 2 is equal to the square root of, take the x values, subtract those first, 0 minus 0 squared, plus, using negative 9, since I started there, negative 9 minus 7 squared. So that gives me the square root of 0. Negative 9 minus 7 is negative 16. I'm going to square that. So it's the square root of 16 squared, which is 256. So it's like going backwards here. So the square root of 256 is 16, is the distance between the 2 points. Problem number 4, the distance between point 1 and point 2. I'm going to use x, start with the first ordered pair, so I'm going to take 10 minus a negative 4, find the distance between those 2 points, plus 3 minus 9, and square them, and then take their square roots. 10 minus a negative 4 is 10 plus 4, so that'd be 14 squared. 3 minus 9 is negative 6 squared. 14 squared is 196. And negative 6 squared is 36. So that adds up to 232. And the square root of 232 to the nearest 10th is 15.2. So approximately 15.2 is the distance. Problem number 6. The 2 points are 7, negative 2, and 4, negative 5. So the distance between the 2 points is the square root of the squares of their differences. So 7 minus 4, the difference between the x's, plus negative 2 minus a negative 6. 7 minus 4 is 3 squared, And 2 minus the negative 6, 2 plus 6 would be 4 squared. So I have the square root of 9 plus 16, which is the square root of 25. So the distance between them is 5. Number 8, the points are negative 4, 7, and negative 9, negative 5. So the distance between those 2 points would be the square root of the difference between the x's, negative 4 minus a negative 9 squared, plus 7 minus a negative 5 squared. Negative 4 plus 9 would be the square root of 5 squared, plus 7 minus a negative 5 would be 12 squared. So that'd be the square root of 25 plus 144, which adds up to 169, and the square root of 169 is 13. Number 10, we have 3, negative 7. The distance between that point, and 12, negative 8. So the distance is equal to the square root of the difference in the x's, 3 minus 12, plus the difference in the y's, negative 7 minus a negative 8. So that would be the square root of negative 9 squared, plus that would be 1 squared. So that would be 81 plus 1, the square root of 82 to the nearest 10th is 9.1. And the last problem on this section here, number 12, the ordered pairs are 10, 11, or the points, negative 11, and negative 9, 3. So the distance between those 2 points is square root of 10 minus a negative 9, square that, plus a negative 11 minus 3 squared. 10 minus a negative 9 would be 19 squared. Negative 11 minus 3 is negative 14 squared. 19 squared is 361. And 14 squared is 196. And adding those together, we get 557. Take the square root of that, it's 23.6. Now we're on page 538, and it's 1 to 38. So we're doing number 2. They want us to assume all the variables represent positive real numbers. So we're going to simplify these. 4 radical 7 times 2 radical 7. 4 times 2 is 8. And we can put the 7 times 7, which is 49. So that simplifies to 8 times 7, which is 56. The square root of 49 is 7. Problem number 4, we have the square root of 5 times the square root of 5 times the square root of 9. So if we put these two together, we get the square root of 25 times 9, and those are both perfect squares. So the square root of 25 is 5, and the square root of 9 is 3. So that's 15. Number 6, we have 6 radical 2 times radical 5. We can take 2 times 5 and put that together underneath the radical sign, and that's 6 radicals, 10, and there's no perfect squares in 10. Number 8, we have the square root of 5 times the square root of 20. Multiplying those two together, since they're both under the radical, we get the square root of 100, which is 10. Problem 10, we have the square root of 7 times the square root of 35. And that is the square root of 7 times 35, and in 35 you have another 7. So you have the square root of 49 times 5, and the square root of 49 is 7, radical 5. Number 12, you have 9 radical 242. We need to find a perfect square in there. If there is one, we could divide that by 2, and we get 2 times 121, and 121 is a perfect square. It's 11 times 11, so take that out, and we get 9 times 11 radical 2, so it's 99 radical 2. We have the square root of 4/9 times the square root of 18/4. We could put those both underneath the same radical and cancel. 4's cancel, the 9 goes into 18 twice. So we have the square root of 2, which doesn't have any perfect squares in it, so that's the answer. Problem number 16, we have the square root of 7/3 times the square root of 3/28. Put them underneath the same radical. Cancel. We get the square root of 1/4, which is the square root of 1 over the square root of 4, which equals 1/2. 18, we have the square root of 4/5 times the square root of 10/36, which is equal to the square root of 4/5 times 10 over 36 underneath the same radical. Cancel. So we get the square root of 2 over 9, which is the square root of 2 over 3, since we can separate those. Problem number 20. The square root of 2 2/5 times the square root of 1 2/3. Turn those into fractions under the same radical. So that's 12/5 times 5/3. You can cancel the 5's. The 3 goes into 12/4. So now we have the square root of 4, which is 2. Problem number 22. We have the square root of 15/11 times the square root of 1/3. Put them underneath the same radical, so that's 15/11 times 1/3. The 3 goes into 15/5. So now we have the square root of 5/11. We're going to have to rationalize that. So that's equal to the square root of 5 over the square root of 11. I want to get rid of the square root of 11, so I need to multiply it by itself, the square root of 11. On top, that gives me the square root of 55, and on the bottom, the square root of 11 times the square root of 11 is the square root of 121, which makes 11, so it's rationalized. 24. We have 5 radical 48 over radical 39. That's equal to 5 over the square root of 48/39. And we could divide by 3, so that's 5. 3 goes into 49, 16, and 3 goes into there, 13. So now we have 5 radical 16 over radical 13. So that's 5 times 4 over radical 13. Or 20 over radical 13. But we have to rationalize the square root of 13, so we're going to multiply by itself, top and bottom. So we end up with 20 radical 13, and the square root of 13 times the square root of 13 is the square root of 169, which is just 13. And there's our answer. 26. We have 7 radical 40 over 49. So that's 7 radical 40 over radical 49. So that gives us 7 radical 4 times 10 over 7. The 7's cancel. The square root of 4 is 2, so we have 2 radical 10. We have 15 radical 5 over radical 90. If I put those together, I can cancel out the 5's, and I get 1 over 18. And the square root of 1 is just 1, so I have 15 over radical 18. I'm going to go ahead and simplify that a little bit. It's 9 times 2. So that's 15 over 3, because I could take that out, radical 2. And the 3 goes into 15 5 times. So I have 5 over radical 2. Rationalize that by radical 2, so I get 5 radical 2 over 2. Okay, something went wrong in that one. I copied it wrong. Okay, let's go back. I'll quickly fix that. That should have been 6. So that's going to be 15 over the square root of 6/90, which is 15 radical 1 over radical 6 goes into 90 15 times. So that's 15 over radical 15. And if I want to rationalize that, which I have to do anyway, I get 15 radical 15, and the bottom comes out 15, since that's a perfect square. So my answer is radical 15. Problem number 30. I have the square root of 7 times the quantity 6 minus radical 2. Use your distributive property and multiply each of the binomial, each part of the binomial by the square root of 7. So I get 6 radical 7, and we always put the whole numbers in front of the radicals. Minus the square root of 7 times the square root of 2 is minus the square root of 14. 32, we have 3 radical 5 times negative radical 10 times the square root of 27. So that's a negative 3 times 5 times 10 times 27. Let's see if we can find some perfect squares. I know 10 is a 5 times 2, and 27 is 9 times 3. So I now have negative 3 square root of 25 times 2 times 9 times 3. Square root of 25 is 5. So take that out. Square root of 9 is 3. Take that out. And I have left 2 times 3, which is 6. So negative 3 times 5 is negative 15 times 3 is negative 45. Radical 6. 34. We have 5 radical mn squared times negative 2 radical m. Multiply the whole numbers together, I get negative 10. Underneath the radical, m times m is m squared, n squared. They're both even, so I can take their square roots. Negative 10 m n. 36, I have negative r times the square root of r squared s minus s radical r squared s. Multiply the numbers in the terms in front of the radicals, so that's going to be positive rs. I have r squared times r squared, that's r to the 4th, and s times s is s squared. And those are both perfect squares. So the square root of r to the 4th is r squared, and the square root of s to the squared is s. So that's what comes out, and then r times r squared is r cubed, and s times s is s squared. And the last problem, the square root of x times the quantity, the square root of x to the 5th plus 7. Distributive property, the square root of x times the square root of x to the 5th is the square root of x to the 6th. And 7 times the square root of x is 7 radical x. The square root of x to the 6th is x to the 3rd plus 7 radical x, and that's all we can do. That concludes the evens. Be sure you check the answer key in the back for the odds.